Okay, so welcome. This is the second session for Helenus. As I mentioned on the previous session, I was going to structure this in 2 or 3 sessions. In the first one, I tackled the synchronous API, and on this one, I'll tackle the asynchronous API. I'll try to repeat what I mentioned on the previous talk, what I find important if you're just jumping in on this one. Basically, what Helenus is a collection or is a library, a Scala library that lets you connect with Apache Cassandra or DataStax Enterprise. The idea of this library is to allow users to work with Cassandra in a type-safe manner, but also in a practical manner or in a pragmatic manner. There aren't complicated abstractions. The idea is to keep the API as simple as possible and not introduce anything complicated like monads or transactors or anything like that. So why use this tool? So I think that this is an alternative that you can use to connect or to use Cassandra compared with Phantom or Quill, which are good libraries. But the fact is that this library, Helenus, comes to serve a need or a workflow on the project that we have that is not necessarily the same as the one that Phantom or Quill satisfy. This, nonetheless, Helenus takes inspiration from Phantom and Quill, and also takes a bit of inspiration from Anor. What we believe is that we should put our SQL or SQL queries in center place, because these are actually the things that are going to go against the database. We all know that there are some libraries such as Hibernate or any ORM solution that makes working with databases a bit complicated from time to time, especially if we want to debug or we know what query we want to execute, because it's more performant or gives us more control how to approach communicating with the database. So yeah, that's what Helenus is. We have a wiki that goes and explains in great detail how to use it, repeats a bit the motivation, and also explains or defines some concepts that are either coming from the Java driver, from the Cassandra Java driver, which Helenus builds upon, and some concepts introduced by Helenus itself. So in a sense, the concepts that are coming from the Java driver are 3. So a prepared statement, a bound statement, and a type codec. Ideally, what we have is when we have a prepared statement, what we do is we define queries that are going to be prepared and are going to be used multiple times. Usually we define a query, a statement, as a string literal, and we hand it over to the driver so the driver can validate and parse and validate that query. Once we have a prepared statement, whenever we want to run that statement against the database, we need to bind some parameters, which could be 0 or more. Once we have this bound statement, what we do is we execute it with a session. Then we also have type codecs. So type codecs is how we tell the driver how to encode or decode a particular JVM type, such as a string, or boolean, or an int, and also more complex types such as collections or UDTs. Helenus brings some concepts on top of that, such as ScalaPreparedStatements. So this is an extension on the original prepared statement. A ScalaPreparedStatement is a prepared statement, is an extension of this, and also is a construct or an abstraction that can be treated as a function. So its idea is that we can think about prepared statements as functions that once we provide the input, its input parameters, which correspond to the bind parameters, we get a bound statement out of that. Actually, what we do is we actually get a Scala bounce statement that's such as like in the case of the ScalaPrepared statement, this is also an extension of the original bounce statement. Then we also have RowMappers. So RowMappers tell Helenus how to extract or how to convert a row from a result set into some case class or into some type that we want to extract this or convert this value to. There are different types of RowMappers, so usually we can think about a RowMapper could be something whenever we are selecting or projecting against a single column, then we have a simple RowMapper because we only want that value. We also have a tupled RowMapper, so whenever we are querying more than one column, but we don't want to map that each row to a particular case class instance, we just want to get the values. We just care that we have we get the values out, and that's when we get a tuple. And finally, we have a RowMapper for case classes that can be derived implicitly. Then we have adapters. So adapters, if a RowMapper lets us take things out of the database, an adapter can let us put things in. Originally, its intention was to be able to hand over case class instances into a ScalaPrepared statement, and then from there execute without having to map each one of the bind parameters. Actually, it can be used for more than that. It's not necessarily only for dealing with case classes. Maybe there's some alternative that we can adapt from some type A to a type B. Then we have a mapping. So a mapping is an abstraction that was added recently and brings these two previous concepts together under the same abstraction. So a mapping is an adapter and is a RowMapper. And actually its goal is to be able to support that Helenus supports ScalaPrepared statements with more than 22 fields or more than 22 bind parameters. We also have a column mapper. So usually a RowMapper, when it's derived implicitly, it will treat it will map columns to fields in a one-to-one relationship, meaning that if we have one field, let's say ID, and that's of type string, then the RowMapper would expect a column also named ID with the same type. Sometimes we could come up with something that's more complex, such as, let's say, a position with latitude, longitude, and altitude. And instead of introducing a complex UDT, what we could do is we could map each one of those values to different columns. Internally in Scala, we would use a case class, such as, let's say, a position or coordinates, and we would, with this column mapper, we would be able to define how we are going to map those three columns into this complex type without, again, defining the UDT. We also have a column naming scheme. So a column naming scheme is how we define how columns, or actually case class fields, are mapped into column names. So usually in Scala or in JVM languages, well, actually in Scala and Java and Kotlin, maybe no in Clojure, we usually use camel case to define our field names, such as, for example, hotel ID. So this, when going to the database, would be usually with snake case. So a column naming scheme allows us to define what's the possible translation that needs to happen between fields and columns. And finally, we have a pager. So a pager is a way to iterate through results in a paginated fashion. Its goal is to bring the different iteration methods or the different iteration methods that we have over the results, whether that's the synchronous API, the synchronous API, or the reactive API, under one umbrella, because all of these, they work differently from the perspective of the user. Okay, so having that said, we also the wiki goes over in great detail how these different pieces work together whenever we are extracting results or iterating these results. We also have support for streaming libraries such as Peco and Aka. And we also offer some examples, some example projects. So yeah, that's something that we can do. So let's jump ahead and let's talk about the project in question. So as in the previous session, I'm going to go over this example project that goes over hotels. So there is an O'Reilly book called Definitive Cassandra, and inside there is a modeling exercise that goes over hotels and reservations. So in this project we are only going to consider the hotels section. We are going to keep the reservation parts out of it because, well, we would be repeating ourselves again. So in this case what we have is we have different tables meant to answer different queries or different questions, such as find hotels near given a point of interest, or find information about a hotel, find points or points of interest near a hotel, then find available rooms by hotel and date, and finally find amenities for a room. We also have a UDT called address that has 5 fields, and that's used on the hotel, the address, or either the hotel or the boy. So for that, what we do is we have one repository which answers each one of those questions or executes each one of those queries in different methods. These different methods then rely on another abstraction or another class that defines the queries themselves. So in this case, what we have in the companion object of the repository, we have the different queries that are executed. This is not the only way to define the queries, but we just find that this is also a nice way to relate, to put all the queries in one place, even but also denoting or linking it together with the repository. Not that it needs to be this way. It could, these queries could be regular fields inside the repository, or wherever you see fit. So what these queries are doing are, it's on the one hand is registering the UDT, because, well, whenever we are using UDT codec, we have to register it against the codec registry that the session provides. So that's what we are doing. Then we are preparing each one of the queries. So unlike the previous session, notice that now we are using the prepare async method, and so we can prepare the queries on another thread and don't block the execution on this thread. And then we are converting that completion stage into Scala future, and that's basically what we are doing for each one of these queries. So in this case, you can see that we are answering one of the queries, like the hotels by a given point of interest, or selecting an hotel by ID, and so on. We have the different insertions, and yeah. So we can take a look at one of the methods that we are using to query. So on the one hand, we are importing, we are finding hotels by points. So we have a point of interest name, and then for that we return a feature. So we are saying that we are going to execute this query asynchronously, and we're going to get a sequence of hotels. The caveat that I'm going to give right now is that the way that the synchronous API and the asynchronous API on the Java driver work a bit differently in terms of the results, or how we get the results. Usually when we are working with Cassandra, is that we, and the synchronous API, is that we execute a query and we get results in a paginated fashion. We don't see it. The pagination works under the hood. We can get them all in one go. So whenever we are transforming an iterator to a strict collection, that's when we are, let's say, fetching all the rows. And there's a warning, if you see on the Java docs of this method, that we should only execute this if we know that the amount of rows or the amount of results that we're going to get out of the database is relatively small. Otherwise, we may incur in getting, well, too many results. So usually that's what we do. The most common approach is that we get an iterator and we consume elements one at a time. And then on the synchronous API, there is a blocking method that continues to return results without the client knowing that fetching happens. Now, with the asynchronous API, this pagination doesn't work under the hood. We have more control, and we are the ones defining how we are iterating through those results. Nonetheless, in this case, in this instance, we are in control of that. We are going to iterate through the results, but we are not going to leak the abstraction of how that's done through the clients, and it's going to be left inside the repository. Obviously, this is not the only way. Could be your use case could require you to expose these internals, so you could let not the repository but someone else, some other part of the code, have control of how these results are extracted, are iterated upon, and so on. So yeah, let's take a look at that, and then we can see what you can do. So after we have defined the method, what we do is we import some futures converter, because we need to convert from the Java future into the Scala future. After that, we use a for comprehension to step through each one of the futures. In this case, the first future that we have is the prepared statement itself, because we prepared asynchronously, so that gets turned into a future. So after that, we bind the name, and after we have the bound statement, we can execute this either synchronously or asynchronously. In this case, we are doing it asynchronously, and again converting it to Scala, to a Scala feature. That gives us the first page, and then what we can do is, once we have that page, that's an async result set, we can fetch more pages if there are any. And in this case, this is what we usually would return, the first page, and then some abstraction or something that would allow client code to iterate through next pages. In this case, what we are doing is we are using this method consume pages that will fetch each one of the pages. So we get the initial page, and then that will give us a future of iterable rows. In this case, what you have is we have a recursive method that checks if there are more pages, and if there are more pages, we fetch the next page. So this is a method coming from the Java driver. We have to convert it to the Scala future, and then we consume more pages. And then if that's not the case, we would just return the current page. So that's the latest page that we have fetched so far. When we have to roll up the recursive method, what we do is we concatenate the current page with what we fetch on the next page. So this would consume all the pages and return them in one iterator. One iterable, not one iterator. So once we have that, what we do is we iterate through, or we map over each one of the results. So this would be a row. Then for that row, we get the UDT, so the address, and we also construct an hotel by point of interest. So we have the hotel ID, the name, the phone, and finally the address with a conversion method that converts from this UDT value into an address. Finally, once we have done that, we map one more time over the future, and we convert it to a list. Yeah, so, and that's basically what most of the methods are doing, are getting the prepared statement from the future that when we prepare them, are binding the statement, then they are executing the first page and doing something with that. So okay, let's see if we can introduce Helenus and make this simplify this and see how we can use Helenus in our code base. So if we go to the project's GitHub page, we can see that the installation only requires us to copy this into our dependencies. So let's go ahead and let's put that. So once we have done that, let's refresh the project. And actually, let me show you. So one thing that we can do is we can just run the tests, and yeah, all the tests passed. So let me just shut it down because last time I forgot to run it again to reload the project. So let's do that. Okay. So after that, the first thing that we need to do is we need to mark our SQL session as implicit. I already done that, but this would be the second step after importing, or let's say introducing Helenus as a dependency. Then after that, the next step is to bring Helenus into context or to import it. So that's what we're going to do. Do it like this, and then we have Helenus into context. So what we can do is we can use some extension methods defined in the library to convert this into a Scala prepared statement. So let's go ahead and let's do that. Let's delete this, and so all right. So once we have done that, then we can do is SQL Async. So because on the previous session, what I showed you is that we were using to-SQL. In this case, we don't have SQL available because actually we do SQL. Yeah, sorry, my bad. So we do have one. One thing that we could do, or that could happen, is that we don't have access to a strict SQL session. We could have access only to a future session because the driver also allows us to create the session asynchronously, and in this case we can still prepare this. So this will work. Nonetheless, let's keep it simple. It's just something that maybe I can show you later. Anyway, once we have that, after we have transform this string into a SQL query, what we can do is we can prepare that query, and with the prepare method, and this prepare method takes different type parameters. It takes one type parameter for each bind parameter that the query defines. In this case, point of interest name, that's of type string. So let's do that. Let's introduce this, and once we have done that, we have a Scala prepared statement. So notice that we have a future of a Scala prepared statement 1 that takes a string and returns a row. Now let's go back. Notice that the compiler is not complaining, and if we run the tests, then everything should still work. Yeah, so everything works. This goes back to the fact that I mentioned that a Scala prepared statement is a regular Java driver statement, and also by extension the Scala bound statement is also one. So, but again, that doesn't stop here. We can also simplify this a bit. So what we can do is we can say, okay, we have our queries, and we have by POI. What you can do is we can say execute async and execute one with the value that we are here. So once we have done that, let me see what's missing. Yes, so actually another thing that we need to do is we need to bring Helenus into context here as well. So let's do that. So once we have done that, we have a feature of a map async paging iterable. So this would be the async result set. This is the way that I'm going to continue. But fair to say that actually I mentioned that ScalaPreparedStatements allows us to treat them as functions, and that's still possible, but it's only possible on the with the synchronous API. So we cannot get a future of a bound statement using functions, otherwise there would be an ambiguity regarding the function itself. So we can, if you want, we can still do, here we have the ScalaPreparedStatement, and we can still treat this as a function, and this will give us a Scala bound statement. Anyway, just like the synchronous API, we have this shorthand syntax that binds and executes the statement. So once you have done that, notice that we have an iterable row. So what I can do is I can map that, and I'll probably not map it, but let's say this would be the first page. Now once I have this, I can also, from the first page, I can consume, I should be able to consume, no, because the async iterable is not an async result set. So yes, it seems like now I'm a bit stuck. So how do I work with this? How do I get results out of this? So what we can do is we can use some other extension methods, such as the same ones that we had previously. So fetch page, and has more pages. So let's see if we can actually not change this code that much. So I'll show it step by step, so we can refactor it. So let's go ahead and let's refactor consume pages. Let's duplicate it. Consume pages, map literal sync. So then this should be, this is going, no, we don't need that. Yeah, we don't need to map async page iterable. So this would be, let me check one more time. So I don't forget, mapped async page iterable. Okay. So mapped async page in iterable of type row. So let's import that. Once I have this, what I can have is I can have the same methods, right? So actually, let's call it result set. We don't need to do this. So once I've done that, what I can do is I can change it to a flat map, because this is going to execute it somehow, going to fetch the pages in different asynchronous competitions. And once I have this, the first page, I can consume the pages. So I can do this, and let's do it like this. So now I have a feature of iterable rows. Now I need to convert it to the to hotels. So let's go ahead and let's do that. So here I have rows, and let's copy this. We're going to need it. So let's do rows, view, let's space map, and then let's do do list. Okay, so if we did everything correctly, this would be a future. Okay, that's interesting. Now let's get rid of the view. Should have taken out. Okay, maybe IntelliJ is complaining. It's not updating the values properly. Anyway, so now if we run the tests, yes, this still works. And now you can see that the execution and the binding and getting all the pages is just one line. We could also do it with photo comprehension. Now there is another way to execute this, and that would be once I have this, what I can do is I can use some of the extension methods, such as once I have the result, so the first page, what I can do is I can call iterator or iter. Iterator was already taken, but iter takes a finite duration, and what this will do is it will provide us with an iterator of rows. This will behave in the same way as the asynchronous synchronous API. It will feed us with results one at a time, and when the next page has to be fetched, it will produce a blocking execution to fetch the next page. The timeout is just a way of controlling how much we want to wait for that next page to be fetched. But in a way, we are simulating the synchronous API with the asynchronous one. We can also get pages. So in this case, instead of giving us back instead of having to get new values and iterating upon, what we could do is we could say we want the next page, so this would be the second page, and then next mapping as the next iterable, so iterable. All right, yeah, that's true. So yes, this is a feature. So we have that. So now you can see that. Okay. So X is a feature of an option of iterator and row, iterator of row and map paging iterable, paging iterable. And what this will give us is that it will give us a sum if there are more results. So if we actually have a next page and a way to get that next page with the map async paging iterable. Otherwise, it will give us a none, and then we would know that all the pages are complete, or we have consumed all the pages. So let's go ahead and let's remove this. We don't need that anymore. Here we are using all Scala features, and let's run the test again. So yeah, that should work. So once we have done that, then we can get rid of all the intermediate steps. Now let's take a look and let's see if we can do the same thing for the next method, and we'll also introduce UDTs or UDT codecs. So here we are finding a hotel by ID, so that can return results in an asynchronous execution that can give us an hotel or not, depending on the option, on the value of the option. And we do exactly the same. What we do is we bind, we get the prepared statement, we bind the parameter, we execute that bound statement, and we get the first result. We don't need to go further because, yeah, by ID we only have one hotel by ID. Once we have done that, the one method can give us gives us no if there are no results. So we have to wrap it with an option. Once we have done that, what we can do is we convert this row into a hotel. So let's go to the query and let's do the same transformation. let's get rid of this part. Then let's convert it to SQL Async, and let's prepare it with a string, because the IDs, the hotel IDs are strings. Again, one more time, this is still compiling, so it shouldn't be a problem. But nonetheless, let's go ahead and let's do the transformation now. So we have queries by ID, and we execute async, we provide the ID. Then what we are going to do is we are going to map. We don't need to flat map because we are only going to get one result. We don't need to execute the consume pages. So let's do a result set, and then from this result set, so you can see that I'm following the same structure as I'm following here. And what I can do is I can wrap this result set inside an option, and then map this let's go 1, so get the first row, and then we can go ahead and convert this. Let's delete this, and let's get rid of the converter. Once we have done that, we have transformed this execution to use Helenus, and the tests still pass. Now, one thing that we can do is we see that if we go to the case class hotels, we can see that it has an ID, a name, a phone, an address, and some points of interest. And if we check the hotels table, we see the same fields. We see an ID, we see a name, we see a phone, an address, and some points of interest. So one thing that we can do is we can construct instances of hotel without having to map the columns to fields manually. What we can do is we can use this RowMapper abstraction that I mentioned a moment ago. So let's see if we can introduce that RowMapper. Let's do it in the companion object. So RowMappers are used or are defined or are expected, implicitly. Let's define it in the companion object so the compiler knows that it can find it here. So first thing that we need to do is we also need to import Helenus, and we are going to import the RowMapper. So a RowMapper works quite simply by defining an implicit value of type RowMapper. This RowMapper takes a type parameter of the type that we're expecting to get out of the row. In this case, it would be hotels, and the hotel, we can use this instantiation method or the apply method on RowMapper, and this will give us a RowMapper back. We can also, as I mentioned, we can use a column naming scheme to map fields into case classes, how they are related to each other. In this case, it doesn't make, it's not needed because there are no fields that have 2 or more words. There is no underscore, or let's say camel case doesn't have to be compared to snake case. Anyway, what we could do is we could say implicit, and then the column naming scheme, and here we can say that we want a snake case. Let's do this. Actually, let's simplify this. Snake case. Yeah. Anyway, another thing that we could do, and this is something that we follow on the project, is that we send all these definitions inside the package object of repositories, or whenever let's say the package that takes care of interacting with the database. So we have all the configuration centralized in one place, meaning that all the columns are expected to be with the same naming scheme. All the columns would be snake case. This is just a convention, but yeah, anyway, it would be possible to have hotels with snake case and maybe, I don't know, reservations with camel case, if that's how it's like. We can also have a fine-grained control of how these columns are mapped to fields and the other way around. and that's with a method called renamed inside RowMapper. So rename also takes a type parameter of hotel, so because it needs to know what's the what's the type. And actually I'm going to show you this in a moment, but we could say, okay, ID is actually mapped to hotel ID. Now this value is not going to be affected by the column naming scheme. This is the actual value that is going to be used. So in a sense we are overriding the behavior just for this field. Anyway, in this case we don't need it, so let's put hotel back and let's see how we use a RowMapper. So once we have the RowMapper, we can define it in the query. So here in this query we know that we are putting a string, and for as of now we are getting a row back. If we use the as method and we use as type parameter the same the type that we're expecting to get out, then that will give us a ScalaPreparedStatement of that takes a string and returns a hotel. So this method requires that implicit RowMapper. Now obviously this is complaining, and because right now we don't have a we no longer have a row, we have a RowMapper. So let's see if we can remove this part. So just to compare, let's copy paste this, and now let's once I have this, I still have that feature of an async iterable. Let's map that. So let's say that this is a result set, and what we want is we want to use a method called next option. So this is something similar to what we had on the asynchronous API, on the synchronous API, sorry, that we could iterate one result at a time and we would get an option instead of a null value. But this is a bit different. So next option on iterable results doesn't return only the value that we're expecting to get out, it also returns the paging iterable that we should use if we want to continue to iterate or we desire to continue to iterate that that result or those pages. In this case we just want the first result, so we need to change that a bit, but let's see if we can make this a bit prettier, because I think that we are getting too many maps and flat maps. So let's go ahead and let's do this. Now once I have this, I can get the first result, and yeah, so result, and let's do next option. Now what I can do is I can yield on that, and what I want is I want to have an option, and I just, let's say, hotel, and then I don't care about this result, and I'll just get the hotel. Now notice that I don't have row anymore, I have the hotel type because of the RowMapper. And now if we run the tests, I get some problem. So this is one of the issues that come from shapeless. So Helenus relies heavily on shapeless to derive a lot of RowMappers and adapters and some codecs. So in this case, and also the messages are a bit cryptic from time to time. In this case, it says that it cannot find an implicit value of parameter derived from mapper of hotel. And notice that this is not complaining on the repository, it's complaining on the hotel class. So the problem stands here. Usually shapeless what says is that whenever we find an error like this, we should simplify the case class and see which one is the fields that we cannot derive this RowMapper from. In this case, I know that it's the address, so Helenus brings type codecs for each one of the regular fields, such as strings or ints. Also brings type codecs for tuples. We have native support for or first class support for Scala tuples into Cassandra tuples. We also have type codecs on collections, but obviously the driver, or sorry, Helenus doesn't know how to map an address to a UDT. So, and this could be something that could have been done, let's say, with automatic derivation, but we prefer to leave this as a semi-automatic derivation. So, since we know that we need to provide a type codec for this, so Helenus knows how to map it. Let's import Helenus here as well. And now what we want to do is we want to define an implicit type codec. So this type codec, as I mentioned before, comes from the Java driver. So in this case, we want to encode or decode an address, and the way that we do that is with the codec and UDT off. This then takes a type parameter of the codec, and this would be of type address. This method also takes some optional parameters such as the key space or the name of the type, if it's frozen or not, and also the column naming scheme if the UDT fields are mapped differently than the case class fields. So once we have done that, then we should be able to run the tests. And now it's complaining because of this. Yeah, so now it's executing and everything worked correctly. So once I have done that, I can simply simplify the previous method. So this previous method is still using get UDT value and from UDT value. So let's get rid of that. So Helenus also brings some extension methods on rows, and what we can do is, so long as there is an implicit type codec, we can just do get call, then the type that we want to get. So this method, this get call or the get column, is a single method defined so we can get different values in a unified way. And then what we can do is we can get a column of type address, and once we have that, we know that the column name is address. Now we can get rid of that. If we run the test again, then test bash. So since we have done that, we can let's see what we can do. Yeah, let's continue with something more. I was going to delete the mapping like I did here, but yeah, I'm not going to do that yet. If you see, this should still be used when we are inserting an address, so I'm not going to do that yet. Like I did on the synchronous session, I'm going to do that later. So the other way that we can define statements or ways to interact with the database besides ScalaPreparedStatements is with interpolated queries or interpolated statements. So this works a bit similar to ANORM, or is inspired by ANORM, where we define the queries in place. So let's go ahead and let's do that. So let's do it for points of interest. So let's go to the query. Once we have done that, let's copy this and let's go to, where is the method? Yeah, here it is. So what we can do is we can do this, and we can say that this is a SQL async, we want to interpolate the value for the ID, so we use that. Now what we have here is we have a future of a wrapped bound statement. So this is another type of bound statement that Helenus provides. So once we have that, what we can do is we can flat map this method. Oh, sorry, no, yeah. So what we want is we want to execute async, so I was forgetting about that. So once we have that, just like we were having before, we have the result set, and what we can do is we can consume the pages. So let's go ahead and how do we do that? Oh yeah, okay, let's copy paste. Let's be a bit lazy about this. And once I have done that, then I have our iterable of rows. So let's map on that again. I have the rows, and I can copy paste this, place it there. Sorry, yeah, because I need to map one more time over the rows. So let's do row. And once I have this, I have an iterable of point of interest. So let's convert this to a list, and then this should be the same. So what we're doing here with SQL or SQL Async is we are defining a prepared statement. So this is actually prepared. There is no even if we don't see the prepared statement, we get just a bound statement. There is a prepared statement happening under the hood, so this query will still be validated. Actually, we can probably, I can show you how that works. So let's use this method so we can get the string and or the strings, and if we execute the test, still pass. So everything good. Now just to drive the same point again, let's also define a RowMapper for this. In this case, we won't have to do anything special. We have both fields of type string, so this will work from the get-go. So now once I have done that, then what I can do is I can define the method here. So I can say that this is a point of interest. So I use the as method like I was doing on the prepared statement, and once I have done that, notice that I no longer have a map async paging iterable. I have of row, sorry, I have a point of interest because I converted that. So let's do that. Let's try to be a bit more generic about it. This, then this should work. Let's see where it's used. So here, so now this is iterable of a point of interest. I should be able to just do, instead of doing the conversion, what I can do is I can remove that part. The conversion is being done by Helenus with the RowMapper, and I have that. So I have simplified quite a bit how the execution and the mapping and everything works. So if I run the test, then hopefully, yes, it should work. Okay, so let's see the available rooms. No, this is not the one that I want to see. So we could do the same, right? We could do the translation for this method for available rooms, but I want to show you something else. I want to show you that actually we can use this renaming to on the RowMapper. So if you see here, we have the query room amenities, and we are selecting the amenities underscore name as name. So the reason why we're doing this is because I was going to introduce a RowMapper on amenity, and the RowMapper expects, as I mentioned, that the field name can be mapped to the column name. So in this case, it would be 1-to-1. Even if, let's say, the naming will have to be modified from camel case to snake case, sorry, we would still have to have, let's say, some sort of resemblance between these two. So let's go ahead and let's remove that. And if I run the test, then this is going to fail because name is not a column on that row. So let's fix that. Let's see if we can convert this into Helenus and fix that issue. So we're going to remove this part, and no, this part as well. We're going to use to_async like we did before, and then we're going to prepare. Now this query takes two parameters: the hotel ID that we know that is of type string, and the room number that, if I recall correctly, is of type short. But let's just check. So the room number is of type short, yes. So this would be short. Now I do have a ScalaPreparedStatement 2 of string and short, and that gives us back a row. So once I have done that, then yeah, I can still execute the test, and now, oh right, yeah. So that's interesting. I wasn't expecting this. So this is one of the things that we wanted to fix with Cassandra. We want to fix from the Java driver with Helenus, and was that, if you see, there expects this is a compiler error that says that the result type of an implicit conversion must be more specific than any ref. So why is this happening? Because if we go back to the code, we'll see that we are using the bind statement. So notice the error is on the bind method, and is pointing to room number, not to ID. Now if we see here, the bind method is coming, well, actually delegating to the prepare statement. So this is on the Scala prepare statement, but it's delegating on the original prepare statement. Is that this is defining on objects. Now we know that object and any ref are equivalent, but they live on another hierarchy than any vals. So the compiler would complain whenever we wanted to introduce something like this, and we would have to typecast it like this. So we would say we have to define it as the type, or like the boxed instance. Now if I do this, then yes, this still fails, but fails on the name column, not on the execution. So that's one of the things that we wanted to avoid. We wanted to do any kind of boxing. We actually don't need to do that. So if you see, I can remove this, and the compiler will still complain. But if we do it with Helenus, so this actually doesn't complain. So let's do string. Now this is the ID, this is the room number. Then once I have done that, I have the result set, and then from this result set we can, this would be not the result set. I want to constrain the pages. So once I have so I do it. I was doing it like this. Why is it complaining? Oh, right, sorry. Wrong method. Yeah, so once I have that, then I have all the rows, and from the rows I can get all the amenities. Now, as we know, this is not name, is amenity name. So let's use a RowMapper to get rid of that issue. So what we want is just like we did in the other cases, we import Helenus and a RowMapper and amenity. Now we know that we can't use the RowMapper like this because, as I mentioned, this is mapped using the same field names. What we want to do is we want to rename or redefine one of the fields, and in this case what we want to do is we want to rename how name is mapped. So in this case I have amenity name. Had a typo. Yeah. Now once I have done that, I should be able to convert this into as amenity. So now I have all the amenities, and I can just do I don't need that anymore. Oh, right. To set. It's not a list. Okay. So yeah, again, everything was simplified into a single expression. And now if I run the tests, that should pass. Okay, cool. Yeah, I think that's roughly it. Now let's see if we can introduce adapters. Actually, I haven't used adapters that much in the synchronous API. So as I mentioned, an adapter is something that lets us put or convert the expectation that a ScalaPrepared statement has from a case class. So in this case, what we can think is that if we take a look at the insert hotels takes 5 parameters. And we can think that this function is like the tuple version of a function, takes a tuple of 5 parameters that align with the same types that we defined there. So let's go ahead. Let's convert this to Helenus as well. So we are going to say, just like we did before, this takes 5 parameters. So string does the ID, string does the name, string does the phone, address, and then a set of strings. Now once I have done that, I should be able to go back and modify this to say queries insert hotel, then execute. Now execute async again takes 5 parameters, so let's move this here. We're going to use the same parameters. You can see that the compiler is already complaining. So why is it complaining? It's complaining because here the function is expecting an address, it's not expecting an UDT value. So we don't need to convert this anymore. We have already provided the codec. And now here is also complaining because it's not expecting a Java set, it's expecting a Scala set. We also, as I mentioned before, we provide type codecs for collections. Now once I have done that, I should be able to map this and return unit. Yeah, unfortunately, even if we are going to use do an insert which doesn't return any value, we are still getting a map async iterable. So that's how the API works. From there we can usually check, or from an async result set we can check if the operation succeeded or not. So once I have done that, then I should be able to execute the test, and this should still insert hotels into the database. But now what I want is I want to introduce this adapter. So instead of putting all these values in, what I want is I want to let Helenus take over of extracting the string, so the string of the ID, the string of the name, the string of the phone, because I know what I know is that this is going to come from a hotel, so I can use the from method with the type parameter hotel, and then once I have done that, notice that here I have converted the method, and this takes a hotel that is then transformed into the original prepared statement, so a string, 3 times string, an address, and a set of strings, and then gives us back a row. The compiler is complaining because, well, we haven't defined an implicit adapter, so just like RowMappers, adapters have to be defined implicitly. So let's go ahead and let's do that. Now, this is on the SQL adapter, and what I'm going to do is I'm going to now what I want is I want to go from an hotel to all the values that I have, so to this tuple that I mentioned, so this will be a string, then an address, and finally a set of strings. Once I have done that, then what I can do is I can just call the adapter with that same type, so there is an instance method, and what am I missing? All right, yeah, yes. So I don't need to specify the second half. So the compiler already knows that if it can construct this tuple from the hotel, then I don't need to specify it. This is overly, so if I would do this, then the compiler will complain because it wouldn't know what to do with the remaining set of strings. So if I do this, and if I go back to the repository, what I can do is I can notice that here the compiler is complaining because it's not expecting any more 5 parameters, it's expecting only 1. So let's replace that with hotel. So that's what it's expecting now, only a hotel, because we adapted it from hotel. And if I run the test, then this should pass. No. And finally, the last thing that I'll show you is this concept of mapping, right? So we have talked about RowMappers, so that's how we take information out of the database, how we use adapters to adapt the expectation that or the parameters that a Scala prepared statement has, in this case these 5 bind parameters, into our more complex type like a hotel. But we run into issues if this prepared statement requires 23 parameters or more. If you notice here on the adapter is adapting a tuple, and tuples can only have, unfortunately, 22 parameters in Scala 2.13. So what Helenus introduced is another way to prepare statements, and that's prepare from. So prepare from is did I okay, yeah, I think this is a limitation. That's interesting, I didn't expect it. Prepare from, yeah, so this is on the synchronous API. I should be doing is it complaining? Because there is no mapping. So let's define a mapping. So once I have a mapping, I don't need a RowMapper and an adapter because these work the same. So I can do implicit mapping and then mapping of hotel, and I can simply do mapping of hotel. So yeah, in the method. Yeah, so this, just like the RowMapper, allows us to define how we want to rename the fields. So we could say that ID is mapped to hotel ID. Yeah, that's still possible if we want to do that. Okay, so once I have done that, then compiler doesn't complain anymore. So yeah, unfortunately, this is a use case that we didn't expect, but should be there to align both APIs. So we'll add it on next releases. So now, once I have done that, let's go back to the method. And what I do is what do I have here? Oh yeah, okay. So again, this is something that we weren't expecting. So unfortunately, let's do flat map and then let's execute async. Something else to add. So once I have done that, everything should be on a single line. I should be able to execute async directly with a hotel instance without having to flat map anything. But yeah, well, add that later. So yes, all the tests passed. Yeah, so that's basically it. That's what I wanted to cover on this session. I'm planning 2 more sessions, so one for PECO and ACA, so we can see how the reactive API works, and finally another session where we see how to use Pager and how we can bring the different pagination methods back into one mechanism. The library is available on Maven Central, so you should be able to find it by just looking for Helenus. Although, yeah, you'll see the installation in GitHub, how to pull it into your application. I hope that you give it a try, and you'll let us know if you like it, what things do you think that we need to improve, and things like that. So yeah, thank you.